Okay, 3.5 continued. First example is going to be substitution. It looks like this. First equation. Wow, that didn't make that much. Okay, so you're not talking anymore. Not talking anymore. You don't even have paper out. Come on, dude. Paper out. Let's go. So first equation is like this. Second equation is like this. Third equation no, we're going to do the second one in calculator. Calculator's always the same because it's just one method of doing stuff. So we're doing substitution. Which out of the three equations and what variable is the easiest one to solve for? Equation number 2 and the x, right? Because that's the only one that doesn't have a number in front of it. That's why it's the easiest one to solve for. So we're going to rewrite equation 2 down here and then solve. What happens? What's the answer, basically? Solve for x. Right. So I'll just show that step. Basically what I want you to realize that if I take this 5y and I move it over to this side, all that happens is the sign changes. Right? So if I move one number to the other side of the equal sign, it just, the sign switches. That's all that happens. And the proof of that is just by showing the step. But if you can realize that and you don't want to show this step, I'm totally fine with that. So x equals negative 5y plus 9. I'm doing this theory right now. Okay? Question?
Could you also do negative or 9 minus 5y?
Yep. I was like putting the variable first. But it really doesn't matter on this problem. Really doesn't. If it makes more sense to you, go 9 minus 5y, no problem. Okay, so now what we're going to do is we're going to substitute it in to both equations. Right, to the first and third equation. Okay? So if I'm looking at the first equation, again, I'm keeping everything numbered because it's really easy to get lost if you don't keep everything numbered. So we have 2 parentheses, negative 5y plus 9, plus 3y, minus 2z equals negative 1. These things just take a long time. Easy to make a mistake. So next, I just want to just give, yep.
Why is there 153? No reason for that or something?
So, give me a second to understand your question. Because these were the original equations, right? And then I just rewrote number 2 in a different way. Okay? So I'm just keeping, so I know which equation I'm dealing with. That's why I'm numbering them. I think it's confusing otherwise. Yep?
Why are you doing this?
Because it's the easiest variable to solve for, because the x is just x. Right? I could solve for like z right here, but then I get nasty fractions, and it's just horrible otherwise. Okay? So next step, we're going to distribute here. We get negative 10y plus 18 plus 3y minus 2z equals negative 1. So what should I do now? Do you have questions? Combine like terms, good. So I have the y's I can combine. And then if I want to get the numbers on one side, what should I subtract? 18. So I'm totally fine with you guys doing these two steps at the same time, no problem. If it makes more sense to you to write those steps out individually, do so, for sure. Okay, so negative 10 plus 3 is negative 7y, and then I have minus 2z equals negative 19. Okay, so we just made a new equation, right? So this equation is number 4. As soon as you alter the equation, you want to write a new equation number. I mean, I guess technically I could have written it up there, but because I'm going to combine 4 and 5, right? So I want to substitute this x plus 5, or x equals negative 5y plus 9. I just plugged it into the first equation. Now I want to plug it into the third equation. So that third equation was 4z minus 5x equals 4. So I'm going to rewrite 4z minus 5x equals 4. And then I'm going to plug in this x equals negative 5y into this equation. So I have 4z minus, well, because we solved number 2, so you have to plug it into the other two equations. So in this problem, yes, you have to what? Essentially, yes, you will use all the equations. Yeah. So what we're doing is we have this second equation where we solve for x, right? So the first step was to plug it into the first equation using substitution, and now we're going to plug it into the third equation, right? So we solve for equation 2, so we have to plug that value in for the first and third equation because we solved for that equation. And hence why you keep numbering them, otherwise you get totally lost and confused. Alright, so plugging in right here, right? So we have negative 5 times negative 5y plus 9. And then I write the rest of this equation here, right? So the only thing I have left is the equals 4. So, got it? So we have 4z, I'm sorry, I'm in a different color now. 4z plus 25y minus 45 equals 4. So what should I do now? Add the 45 over. And then I have, so when I wrote equation 4, right, the y term came first and the z term came second. So I want to switch the order of these two terms, right? Because the next step I'm going to combine the two equations vertically. So I'm going to write the y term first and the z term second, just so I can keep everything all lined up. Right, we're going to add equation 4 and 5. At this step right here, I'll get my equation 5, and then I'm going to use essentially elimination to solve 4 and 5 for one of the variables. You can solve one of these two equations, but it's just annoying. You have to substitute at the beginning, and then I use elimination. When I saw that's how they did the example in the book, I was happy because I'm like, it's just more tedious. Elimination is definitely better. Alright, so we have 25y, right? I'm just switching the order of those variables. Equals 49. So we are going to combine equation 4 and 5. So equation 4 we wrote up here was negative 7y minus 2z equals negative 19. So which variable should I eliminate? The z, and what do I have to multiply that second equation by? 2. Okay, remember you always need to have opposite signs here. We already do have opposite signs. So as opposed to multiplying this bottom equation by negative 2, I can just multiply it by positive 2, because I already have the negative 2. So I'm gonna multiply this by negative 2, and then write the answer right below. Positive 2, I meant. Because I'm looking here, and if I think about this negative 2, I say, what can I multiply the negative 2 by to make it negative 4? The reason I say negative 4 is because I have positive here. You have to have opposite signs to be able to combine vertically. Okay? So I can multiply that one by positive 2. So I have negative 14y minus 4z equals negative 38. So I'd say most common mistake that people make on these problems is they forget to distribute the 2 all the way across the equal sign as well. So just be careful with that. I see that mistake all the time when you guys do these. So what I like to do is rewrite this equation below. If you guys combine vertically, you know, forgetting about this middle equation here, I see you make a ton of mistakes. So I personally am not going to be lazy. So here's my new equation 4 again, right? And I'm going to rewrite equation 5 down here, just to prevent you from making mistakes. So we get 25y plus 4z equals 49. Now I can combine these 2 vertically. So, right, we haven't even solved for a single variable yet. Just want you to understand that, right? We have done all of this math, and we haven't even solved for a single variable yet. That's going to happen in the next step. We're going to solve for what? We're going to get y here, then we have to plug it in and find x, then we have to plug it in and find z. So you can see how long these problems are. You're only going to have one of these problems on your test. It's going to be either substitution or elimination. I'm not telling you which. Okay? That's how I am. Alright, so what do we get here in this first part? 11y. Right? This middle part cancels. 49 minus 38 is also 11. So y equals 1. Yes. So all of that math to get y equals 1. Right? Yeah, I'm going to take this y equals 1 and plug it into this equation right here because it's already solved for x. So I'm going to plug y equals 1 into this equation because we already have x by itself. So x equals negative 5y plus 9. Because this one's already solved for x, it's going to be the easiest way to do it. If I sub-number that 1 into the other 2 equations, then I'm going to have to use elimination again. So it just makes more steps. So negative 5y is plus 9, right? Okay. And I'm just going to show that plugged in, negative 5y times 1 plus 9. So what do I get for y? 9 minus 5, right? So I get 4. X, sorry. I'm done. It's X, yeah. My bad. My bad. Okay, so X equals 4. Now I'm going to choose one of the equations, right? I have my X and my Y. Can I plug it into this equation? Why not? I can plug it into this equation. Is my math going to be easier if I do? Totally legal to plug it into this one. If you're paranoid, you can plug it into this one, but you just do more math. Right? So I'm going to plug it into this one. 4z minus 5x equals 4. Look at all that Jewish math. So that was equation 3, right? 4z, what was it? Your tendency is I have to have all 3 variables to get the correct answer? No. Okay? Because we know there is a solution to this problem. You end up with no solution. That's incredibly annoying. And you won't on any problem I give you. So negative 5 times 4 equals 4. So I just want to show you ways you can show work. I could show work on this step by just going like this. I'm going to add 20 to both sides, right? Because I know negative 5 times 4 is negative 20. So if you want to show your work like that without that step, it's totally fine. So we get 4z equals 24, so what's z equal? Well, what are some ways you could double check? Calculator, right? Once I get my x, y, and z, then I could plug those 3 into one of the equations, make sure it works. So what I want to see on your test is x equals 4, y equals, it was 1, right?
Yeah.
And z equals 6. So when I grade your test, what I look for first is this. If you have the correct answer, right? I know because I too was a little high school weasel at one point. Like I might BS some of my work if I can't figure out a portion of the problem and hope that the teacher won't notice. But I think like that, so you're not going to get away with it. But I'll check this and I do a quick check of your work. As long as this is right, and your work somewhat matches the work that I have on the key, you'll get full credit. If you have one of these equations wrong, or one of the x, y, and z wrong, then I go back and I look carefully at your work. And when I grade, I think, what % of the problem did you understand? And I give you the points accordingly. Okay, if you understand 80% of the problem, you get 4 points out of 5. Et cetera, et cetera. Yeah. Yeah, you can write it that way, I don't care, I'll understand. But this makes more sense, doesn't it? And I always try to have it make the most sense possible. So just write it like that, it's fine. So what you're talking about is they wrote it like this. Right? Yeah. You can write it like that, I won't take points out. It's X, Y, and Z, right? Always alphabetical order. This is 3-dimensional right here, the graph, right? Because we had Z. But we're not going to graph in 3 dimensions, although it's pretty cool. The only problem is the x and y axis switch. They're not in the same place as they normally are, and that tends to just really screw things up. Okay, next example we're going to do is story problem fun. Yeah. You need that bottom part, right? Look at all that choice math. So anyone struggle on the homework? Yeah, a kid was talking to me, the kid you were working with over the weekend. Like, thank God for all the help, you know? Yeah. Yep. I know. It's insane, right? 3, that's why I only gave you 3 of them. You only get, well, you get 4 tonight. Yeah.
So on the bottom where it goes forward, that's just X, Y, Z.
X, Y, Z, alphabetical order, always. You can just write it like this, though, if that makes more sense. Okay? Okay, we good?
Yep.
Okay. All right. So I'm sorry to say, but you got to write as much of this down as you need to be able to understand the problem. And then we'll talk about it. Yeah, number, the type of chair I would write down, and the statements that'll mess you up is this one right here.
The 3 times as many points.
This is the easy one to write incorrectly. What's beautiful about these as far as word problems, which you may just cringe at the word beautiful in the same sentence as story problem, is because they're 3 variables, it usually makes the problems easier to set up, because they kind of have to be straightforward, otherwise you guys just have no chance, right? It's just too confusing and difficult. So normally these are pretty straightforward, with the exception of the part that I highlighted. That's the tough part, yeah. Oh, yeah. I mean, it's like some chapters you'll find easier than other chapters, but it's pretty much like this level difficulty for the year. So we'll watch those videos, right? Good. Especially if you don't get one example, like one example just goes over your head, you can just go back and watch that single example. You don't have to listen to the whole thing, right? I mean, that's how I would use these videos a ton of the time. There's one difficult concept, one difficult section you struggled with, go back and listen to that video as much as you need to, and I guarantee you it'll make more sense. Skip in there. Andrew?
So, say we just can't write the equations for a week on the test. If we write down like budget equals 7,300 by the shares 125.
You'll get some points. I write, just like I told you, I grade your test based on how much of the problem I can tell you understood. Like I was grading these Algebra 1 quizzes they had to graph like negative x squared plus 1. Really difficult for an Algebra 1 student. Really difficult. Like 98% of you probably could make that graph without a table and be pretty accurate making that graph. Right? Negative reflection across the x-axis, plus 1, your vertex starts plus 1 on the y, going down. Really hard. And I will sit there with my Algebra 1 kids and say, x squared is in the shape of and they go, u. Like I make them chant that, and then they get an x squared one on the graph, and they have no idea. On the test, they do it. I'll say, like, when you plug in a negative number, always, always, always use parentheses. 30% of them won't use parentheses. It's impressive. Those questions. Good happy. Okay, you need more time, right? Writing it down? Okay. Mm-hmm. One of those 4. For the linear programming, the big one? Whoa. Well, but this is different. You have 4 linear programs to look at and try to get down, right? Smart. Yeah, no, smart. And then this is a different section, right? Because we have 3 variables. You have one of these kind of story problems too. Scroll, evil. I get it. It's just hard. You gotta get over it. Gotta get over it. You can get over it. I know all of you can do it. I know you can all do it. Okay, so are we good, right? Ish? Okay, so the very first type of chair I come across is what? Leather. So we're going to call X leather. I would really encourage you to use X, Y, and Z because you're used to seeing it, and if you start using like L for leather, it'll just unnecessarily confuse you. Like all this 3 variable stuff, I would try to stay with X, Y, and Z. Alright? So X is going to equal leather. I love writing highlighted. Y is going to equal what? Mesh. And Z equals fabric. So let's start with this hardest equation to write first. So I've got 3 times as many fabric chairs as leather chairs. So when you're writing this equation, 3 times as many, So I'm going to pick the easiest thing that I know that's 3 times as many as the other. So 3 times as many fabric as, so the fabric is what variable? V. I have 3 times as many V's as I do, what's the leather? X. So I want to make these two equal to one another. If I'm looking at the number part, what do I have to multiply which side and by what to make them equal? I have to multiply x by 3, right? So I have to multiply the 3 right there to make these two equal. It's just to use numbers. One number is 3 times the other number, right? Because 3 is 3 times 1, right? And I know that when I put the 3 into the variable expression, it's going to be the same number. That's why if it's twice as big, I would have written 2 in 1. This time it's 3 times as big, so I'm writing 3 in 1. Plus, yeah, that's true. That made no sense to you though. Right? Isn't 3 times as big as 1? So that's why I use 3 in 1. Just as simple as that. Okay, Anna?
I don't know why you feel well, I never understand that. If someone is full favor to that. Because I want your 3D X, that's my way.
Right. They are going to be equal if I have 3 times as many as the other type. So if I multiply this side by 3, they are going to be equal. I have to write an equation, and the way if I just put a plus right here, then I've got nothing, I don't know what it equals. And I can't solve it then. Like, I have to know what it equals. So the only way I can write this equation is by making z equal to x, and I have to multiply this side by 3 to make it equal. Right? And I'm just using the numbers here so that I can figure out where this 3 goes. If I write it your way, I have no equals. And you can't use the equation then. Like, you have to have an equal sign when we're writing a system of equations with 3 variables. I have to have the equals on all 3 equations. Otherwise, I can't write the equation.
Oh, I think you know, but that's one of your equations vehicles.
Exactly. So my next equation I'm going to write, I think this is the second most difficult equation for you guys to write, is the equation with the 80 office chairs. It's actually a really easy equation to write, but for whatever reason it trips you guys up. So raise your hand if you know what equation it is. So I'm going to start talking and I want to see more hands go up as I start helping you write this equation. Hold on, let me just finish this. Do I know how many? I've got 80 total chairs. Do I know how many of each type of chair I have? No. So what equation should I write? Griffin. Right, x plus y plus z equals 80. Because I don't know how many of each kind I have, right? X plus y plus z equals 80. Because I already wrote the equation dealing with one of them with 3 times the other. So how about the last equation? I think the easiest equation to write. I'm just grabbing all the dollar signs and throwing it into one equation. So raise your hand if you know the last equation. It's the easiest equation to write. And I honestly should see every single hand up. So take a rest and think about it. You're right. Sometimes I go too fast. Tell me. No problem. We're going to do it on the calculator once we're done with it. Yeah. So what's the equation, Julianne? Oh, I thought you were doing that. 3. If the function is 5, I would give you maybe a point and a half on a 5. like where it's just x plus y plus z, you will have, no, it doesn't matter. No. You wanted it would have made it better for you if it did. Okay, what's the equation? Oh, okay, that's just still thinking about. Yeah. It has to have an equal sign. Yeah. Right. Yeah. Okay, what do you get? Jenna, what's the equation? Fantastic, good job. Okay. So we're not going to go through and solve this with elimination because honestly we've probably run out of time. When I give you this story problem on the test, you're going to solve it using your calculator and matrices. Okay? You just have to write the equations. Maybe not exactly this problem, but something like it. Something like it, yeah. All right, so the only issue with what we have here, right, we have to write a 3 by 3 matrix to be able to put this in the calculator. Have to have 3 by 3 matrix. And when we write the matrices problem, the issue is right here because we have to have the variables on the left side and the numbers on the number on the right side equal. So if I have this equations right here, we'll do it over here. Z equals 3x. So let me explain a little more what I'm talking about. When I make this 3 by 3 matrices, it has to go in order like x, y, and z. It doesn't matter which equation you have in which row. You can have any equation in any row. What does matter is it has to go x, y, and z. So the problem is this equation doesn't go x, y, and z, right? So what can I do to switch it around? You have to do what? Subtract. Somebody said it. Subtract 3x. Who said it? Who said that? Subtract 3x. Good job. Was it? Yes, she's lying. Nobody will take credit. So I want to subtract 3x from both sides. Not yet. So I have negative 3x. I don't have a y. What do I put? 0. So plus 0y plus 1z, or just z, equals what? 0. Okay, so you have to transform this equation into this to be able to successfully use the matrices. Yep.
Does it matter if we...
Hour and 40 minutes. Could we... Do you say it again? Oh, could you subtract z?
Yes.
So I'm really happy you asked that question. No. The reason you can is because when I plug these into the matrices in the graphing calculator, I need all the variables on the same side of the equation on the left side, and I need the numbers on the right side. Okay? Otherwise, it doesn't work.
On the story problem on the test, can you use the calculator?
I'll be specific in the directions on what I want you to do. Okay? So first equation, we're going to write 1, 1, 1, right? The coefficients here and here and here. Yep. You don't need to. That's always the question. You guys always want to clear them. It'll just overtype, so it'll be fine. You can reset your calculator if you're hell-bent on clearing it. Yeah. If you really want to, you can, but you don't need to. So 125, 100, and 75? Yeah. Okay. And then the last line is negative 3, 0, and 1. Remember, we're going to multiply the inverse of the first times the second. So what's the second? 80, that's going to be hard to put that in. 7,200 and 0. Okay, so we want to plug that in. Remember to get to the matrix. We're going to go second matrix, over to edit. Go back to where? Yep. Yeah, you'll need to be able to switch it from a 2x2 to a 3x3. Just because you're going to double check every single problem you do so you know you get the correct answer. 2x2? Yeah, if you have just x and y, you need a 2x2 and a 2x1. If I have x, y, and z, I need a 3x3 and a 3x1. Order, are you talking about those order matter of like 3x1? Yes. It has to go x, y, and z, but the order of the equations, like here, here, and here, doesn't matter. But this equation has to match with what this equals, right? You know, all the bigger numbers got to match with the 7,200. Okay, so we're going to plug that in. Second matrix over to edit. I already have it in from second period, so throw that in there. And then you can go second matrix over to edit down to B and put that one in. Yep.
Is there a way to clear your papers without using
No. No. It'll just overtype it. If I had a different matrix in here, when I type the numbering into enter, it's like old school Microsoft Word, where it'll overtype. I always hated that. Yeah, it's probably before your time. I've almost, how old are you guys? Everyone in here, like 16? 15 or 16? Maybe 7? Yeah, I got a couple 17. So I've been teaching for 16 years. I've been teaching for as long as you guys have been alive. Isn't that crazy? Yeah. No, you can go right to B. After you get A and B in, you have to go second mode. So we're going to go second matrix again, over to edit, down to B, and put that one in. You have a question? Once you hit this button right here. Okay. Anyone need more time with this? So we're going second quit. That's the important part. After you enter both matrices, you have to go back to the home screen. Otherwise it doesn't work. And then second matrix enter. The X to the -1 button. And second matrix down to B, enter, enter. So we have 16 lever, 16 mesh, and 48 fabric. No, because again, like somebody up here said, how long is this test going to take? Yeah, it's going to take a long time, so I'm going to let you do some of this calculator. Homework's on the board, it'll be on the website as well. It's page 172, if you want to write it down right now, page 172, 21 through 23, and 32 for the story problem. 6th period, I'm going to make it. And I'll post it on the website, yeah. After school, no, I'm not. Tuesday, Wednesday, or Tuesday is the only one that helps. You should wear it. You're going to end up with crazy mango fingers. It will. Please, do it. Do it. Oh, I'm not Tuesday, I'm on Monday. What's up? Are you just waiting? 27. See ya. Well, hey, ma'am. See ya. Take a picture. Oh, really? Delete some of those things. You know it makes your phone go really slow too if you have too much stuff on it.